In this video, we're going to be going over example 3.8, who qualifies for college sports. So this is similar to the one that we did before, but taking it kind of another step further. So, we're back to looking at the NCAA requirements. And there's a sliding scale, so it's not just related to SAT scores, but also GPA. So for example, students with a 2.5 GPA must have a combined SAT score of 820 or higher to be eligible. Whereas students with lower GPAs need a higher SAT score, and students with higher GPAs can have a lower SAT score. So students with a 2.75 GPA must have an SAT score that's at least 720. So the question's asking what proportion or what percent of all students who take the SAT would meet an SAT requirement of at least 720 but not 820. So we want to state the question over again and draw a picture. So we can call the SAT score our variable x, and we have been told previously that that has a normal distribution with a mean of 1026 and a standard deviation of 209. And we're trying to find what proportion or percent of SAT scores fall between 720 and 820. So as we look at our picture here, this is kind of our standard picture. Again, it's always good to draw this. They don't really have these marked with the standard deviations, but we know because the mean is 1026 that both the 820 and the 720 fall below that. So what we're trying to do is find the percentage of students who score between 720 and an 820. And the way that we're going to do that is find the percent that score below 820 and subtract from that the students who scored below a 720, and that's going to result in us finding the percentage that falls in the middle. So again, we're standardizing this because our table in the back of the book doesn't give us percentages for 720 and 820. We need to find out how many standard deviations away from the mean are those so that we can look that value up in the book. So since we're looking for an x value that's between 720 and 820, we need to standardize both of those values. So we use the z formula, the value minus the mean divided by the standard deviation. So we have 720 minus 1026 divided by 209, which gives us a z value of negative 1.46. And on the 820 side, we have 820 minus 1026 over 209, which gives us the negative 0.99. So we're looking for the percentage of values that fall between those two. So the next step is to go back to the table A and look up the values for 820, which standardized to negative 0.99, and 720, which standardized to negative 1.46. So the area between those two numbers is going to be the area to the left of the negative 0.99 minus the area to the left of negative 0.146. As we look those numbers up in table A, to the left of negative 0.99 was 0.1611. To the left of negative 0.146 is negative 0.0721. And so when we subtract those two numbers, we get 0.0890. And again, that as we look at this diagram, taking this whole area to the left of 820, subtracting the area to the left of 720 is going to result in giving us this piece in the middle. And so when we state our answer, write our conclusion in the context of the problem, we're going to see that about 9%, taking that 0.0890 and rounding it up to 9%, about 9% of high school seniors have SAT scores between 720 and 820.